Okay, good morning, students. Okay, let's start the class. Last class we have discussed about the gas turbines. Okay, now we'll discuss about the properties of steam. Okay, matter may exist in the form of solid, liquid, or gas. Okay, most practical problems in thermal engineering are not concerned with the solid phase, but rather with the liquid and gaseous phase. The most common liquid is water. Water, which can be easily evaporated to form vapor and condensed back to water. Before condensing, the use of water and vapor, okay, we have to know about the knowledge and properties of the behavior under different conditions is required. We should be known is required. Okay, this vapor and gas describe a fluid in its gaseous form, but vapor may be condensed back to a liquid and gas always exist in the gaseous form always exist in the gaseous form. Okay, exists in a gaseous form at a given temperature and pressure. Okay, a perfect gas is sometimes referred as a permanent gas. Air, oxygen, hydrogen, and nitrogen may be considered as perfect gases with the temperature limits and with the temperature limits of thermal engineering. Okay, okay. In this, a vapor sometimes referred as a gaseous phase, which is in contact with the liquid form, nothing but the steam. Steam in contact with water. Okay, such the gas laws are not applicable to vapors. Okay, these gas laws may be applicable to vapors which are free from liquid particles and may be greater than saturation temperature. Okay, according to the given pressure. Okay, in this first we will learn about the formation of steam. First we learn about the formation of steam. In this first we consider 1 kg of water at 0 degrees and the atmospheric pressure will be 1.013 bars. Atmospheric pressure will be 1.013 bar. Okay, contained in a cylinder. Okay, container you can see on my screen. Okay, let the water be heated up slowly at constant pressure and change in temperature and enthalpy will be recorded. Okay, first as heat is added. Okay, as the heat is added, temperature of water increases. When we will heat, automatically what happens? Temperature increases. Okay, at a certain temperature, it will begin to boil. Nothing boiling is nothing but the evaporating. Okay, at this condition, water is said to be saturated. Okay, at this condition, okay, when it is boiling, at this condition, water is said to be saturated. Since any further addition of heat at this point will cause the water to evaporate. Okay, the temperature at this point is called saturation temperature. Okay, the temperature at this point is called saturation temperature, and it depends on pressure. If the pressure is increased, the saturation temperature also increases. Okay, as we know, the pressure increases, the saturation temperature also increases. At atmospheric pressure, its value is 100 degrees. Okay, at atmospheric pressure, the value is 100 degrees. Okay, 100 degrees. The amount of heat supplied to rise the temperature of unit quantity of water from 0 degrees to saturation temperature is called sensible heat or total heat of water. Okay, what we say, uh, what is this total heat of water? The amount of heat supplied to rise the temperature. Okay, the amount of heat supplied to rise the temperature of unit quantity of water from 0 degrees to saturation temperature is called sensible heat or total heat of water. Okay, in this further addition of heat will cause the water to evaporate at constant temperature, nothing but constant temperature Tg. Okay, at constant temperature gas has Tg, and fluid at condition C. At fluid at condition C is called wet steam, is called as wet steam, as it contains water particles. It contains, okay, you can see on my screen. You can see on my screen. Okay, you can see a figure. Okay, in this A to B. Okay, A to B. This is the A to B. Here from A to B, this line from here A to B. Okay, heating of water, nothing but the heating of water. The temperature changes from 0 degrees to 100 degrees. The temperature changes from 0 degrees to 100 degrees. Okay, here the temperature changes from 0 degrees to 100 degrees. Okay, and from B to D, evaporation of water. The evaporation of water, temperature and pressure remains constant. From B to C, what we can see? nothing but the at B2C what happens, the evaporation of water and the temperature and pressure remains constant. Okay, in this I have said that further addition of heat, the further addition of heat will cause the water to evaporate at constant temperature Tg, and the fluid at condition C. The condition at C, the steam is known as wet steam. The steam is known as wet steam, which contains, you can see at the point C, that is a wet steam. That point contains the water particles. That point contains the water particles. When sufficient amount of heat is added, when sufficient amount of, okay, okay, when sufficient amount of heat is added, remaining water particles are evaporated. Okay, what happens when sufficient amount of heat is added, the remaining water particles are evaporated, and the fluid is said to be, dry and saturated steam, and the fluid is said to be dry and saturated steam. Okay, this condition is represented by point D. At point D, you can see the point D is a dry and saturated stream. The point D is known as dry and saturated stream. Okay, during the evaporation, temperature is maintained constant. During the evaporation, the temperature is maintained constant. The heat added to change the unit quality of water at saturation temperature, nothing but to vapor, nothing but steam at constant temperature, is called latent heat of steam. Okay, this point is very important. What is latent heat of steam? Okay, the heat added to change the unit quality of water. Okay, the steam added to change the unit quality of water at saturation temperature to vapor, nothing but steam at same temperature, is called latent heat of steam. Okay, this is known as latent. You can see at the HFG, you can see on my screen, there is a HFG, that is known as latent heat of steam. Okay, already I have said what is this sensible heat. Okay, this, what is this sensible heat? Nothing but the, at atmospheric pressure, it's nothing but the amount of heat supplied to raise the temperature of unit quantity. Okay, here not the quality, here quantity of water from 0 degrees to saturation temperature is called sensible heat. This is also known as sensible heat or total heat of water. Okay, this is the total heat of water. We have discussed all the from what happens from A to B, from B to C, from C to D, and from D to E. From there E, what we will get? We'll get the superheated steam. We'll get the superheated steam. Okay, this is the superheated steam. Okay, in this, the okay, in this, if the heat, if in this, if the heating, okay, in this, if the heating is further continued at point D, the heating, if the heating is further continued at point D, the temperature of steam increases above the saturation temperature. Okay, the temperature increases above the saturation temperature. The steam is then said to be superheated steam. Just now I have said the steam is then said to be superheated steam, and the temperature difference between the actual temperature and the saturation temperature. Okay, the temperature difference between the actual temperature and the saturation temperature is known as degree of superheat. Okay, the heat added during superheat stage is called heat of superheat. Okay, when we add the heat during superheating stage, okay, if we had the heat during that heat is known as heat of superheat. Okay, heat of super, there's a CP, there's a T supersaturated minus TG, nothing but the T supersaturated, nothing but the actual temperature minus saturation temperature is known as heat of superheat. And what is the degree of superheat? Just how you say degree of superheat, nothing but the nothing but the T saturated minus the TG, that is known as degree of superheat. Okay, correct, right? This is the formation of steam, how the steam is formed. Okay, in this we have some definitions. In this we have some definitions. Okay, in this okay, some are important definitions. Nothing but the, what is this saturation temperature? I have said TG. TG is nothing but the, what is the saturation temperature? Okay, already I have said TG. What is this degree of superheat? In this degree of superheat, we got saturation temperature. Nothing but the difference. The temperature difference between the actual temperature and saturation temperature is known as degree of superheat. Okay, what is this saturation temperature? Let's discuss about this saturation temperature. Okay, it is the It is the temperature at which water starts boiling. It is the temperature at which water starts boiling, and the supply of heat at this temperature causes the evaporation until all the water has been converted into steam, until water has to be converted into steam. Okay, saturation temperature depends upon the pressure. Saturation temperature depends upon the pressure. Okay, for water at atmospheric pressure, remember what is the atmospheric pressure? 1.013 bar. Saturation temperature is 100 degrees. Okay, saturation temperature is 100 degrees. 100 degrees, and at 10 bar it is 179.9 degrees. Okay, thus at high pressure the saturation temperature is higher. Okay, that I already have said in the formation of steam. The saturation temperature is at the high pressure, therefore saturation temperature also high. Okay, what is this saturation pressure? Okay, what is this saturation pressure? Okay, it is the pressure corresponding to a saturation temperature. It is a pressure. It is a pressure corresponding to a saturation temperature. Okay, what is this sensible heat? Okay, these are the definitions. What is sensible heat? Okay, what is this sensible heat? Okay, the amount of heat added. Okay, the amount of heat added to rise the temperature. The amount of heat added to rise the temperature of 1 kg of water. Okay, 1 kg of water from 0 degrees temperature, the TG, the amount of heat added to rise the temperature of 1 kg of water from 0 degrees to saturation temperature at a given pressure is called sensible heat. At a given pressure is called sensible heat. Okay, mainly it is denoted by HF. Okay, we know HF is the sensible heat. It is also known as heat of work or enthalpy of water. It is also known as heat of work or enthalpy of water. Okay, it is very important, HF. Okay, okay, what is this HF? Okay, the amount of heat added to rise the temperature of 1 kg of water. Okay, the amount of heat added to rise the temperature of 1 kg of water from 0 degrees to saturation temperature at a given pressure. At a given pressure is called sensible heat. Okay, this is a sensible heat. It is not by HF. Okay, next, what is this latent heat? Okay, latent heat of vaporization. Okay, latent heat of vaporization. Okay, this latent heat of vaporization, the amount of heat added, to convert 1 kg of water, the amount of heat added to convert 1 kg of water at saturation temperature, the amount of heat added to convert 1 kg of water at saturation temperature to 1 kg to 1 kg of dry steam at same saturation temperature at a given pressure is called latent heat of vaporization, and it is denoted by HFG. Okay, its value depends upon the pressure. Okay, its value depends on pressure at which water is heated. Okay, at higher pressure the latent heat is lower. At atmospheric pressure it values uh, 2 double to 56.9 kilojoule per kg. Okay, at atmospheric pressure the value of HFG is double to 56.9 kilojoule per kg. Okay, this is known as latent heat of vaporization. Okay, I will explain you once again what is this latent heat of vaporization. Okay, the amount of heat added to convert 1 kg of water at saturation temperature to 1 kg of dry steam. Okay, it should be converted into dry steam at same saturation temperature at a given pressure is called latent heat of vaporization. Okay, it is denoted by HFG. Okay, next is the subcooled or undercooled. What is this subcooled and undercooled water? What is subcooled and undercooled water? Okay, it is the water at which temperature below saturation temperature. Okay, now in this before in last I have said we are adding the heat. In this we are what we are doing. In this we are below the saturation temperature. Okay, not the higher. It is below the saturation temperature. The water at temperature is below the saturation temperature corresponding to a given pressure. The water at 25 degrees, at atmospheric is subcooled water. Okay, is subcooled water because this temperature is less than the saturation temperature. What is the saturation temperature? 100 degrees, corresponding to the atmospheric pressure. This is known as subcooled or undercooled water. Okay, what is this saturated water? What is this saturated water? Okay, water at saturation temperature, the given pressure, water at a saturation temperature, the given pressure is called saturated water. Okay, water at a temperature below the saturation temperature is termed as subcooled water. Is termed as subcooled water. Is termed as subcooled water. Okay. Okay. Wait a minute. Okay, is known as subcooled water. Okay. Once again, I will tell you what is this subcooled water. Okay, uh, uh, water at the saturation temperature at a given pressure is called water at the saturation temperature at a given pressure is called saturated water. Okay, water at a temperature below the saturation temperature is termed as subcooled water. Is termed as subcooled water. Okay, these are the following definitions. Just now we have discussed what is saturation temperature, what is saturation pressure, what is sensible heat, what is latent heat of vaporization, and what is subcooled or undercooled water. Okay, what is this saturated water? Okay, these are the following definitions which are very important in our properties of steam. And in this steam, we will learn about types of steams. We'll discuss about the types of steam. Generally, we have three types of steams. Actually, we have three types of steams. That is wet steam, dry steam, and superheated steam. Wet steam and dry steam and superheated steam. Okay, first we'll learn about the wet steam. First we'll learn about the wet steam. Okay, in this wet steam, okay, steam that contains water particles. Steam that contains water particles is called wet steam. Steam that contains water particles is known as wet steam. Okay, in this steam, water and vapor exit in equilibrium at a saturated temperature. The water and the water particles, water and the vapor will be existing equilibrium. Nothing but the equal. There will be an equal ratio. Okay, that is known as wet steam. Okay, what is this dry steam? Okay, dry steam. It is the vapor free from water particles. It is the vapor free from water particles. Thus, the steam that does not contain water particles. Okay, the steam that does not contain water particles is called dry saturated steam or simply dry steam. Okay, simply known as dry saturated steam or we can known as dry steam. Okay, what is this superheated steam? What is this superheated steam? If the temperature of the steam is greater than the saturation temperature, if the temperature of the temperature of steam is greater than the saturation temperature at a given pressure, then it is called superheated steam. Okay, if the temperature of the steam is greater than the saturation temperature at a given pressure, then it is called as superheated steam. Due to high temperature, superheated steam gives higher thermal efficiency, and it is used to minimize the specific consumption of steam engine or turbine. Okay, steam engine or turbine. Okay, this is known as superheated. The three types of steam we have discussed. That is the wet steam, dry steam, and superheated steam. Okay, in this okay, in this boiling may be started by lowering the pressure to the saturation point corresponding to water temperatures. Okay, if the pressure falls suddenly below the vapor pressure, boiling occurs rapidly. What happens? Boiling occurs rapidly. Okay, steam bubbles being formed explosively throughout the water. Okay, steam formed by a sudden drop in the pressure is called flash steam. Okay, in this, what is flash steam? Okay, when the sudden bubbles being formed, that is explosively throughout the water. Okay, steam formed by the sudden drop in the pressure is called flash steam. Okay, in this again, evaporation and on boiling are thermodynamically similar. Okay, evaporation and the boiling are thermodynamically similar, but differ in the behavior of the liquid. But there is a but there is a change in the liquid. Boiling is characterized by the formation of vapor. Boiling is characterized by the formation of vapor bubble, formation of by the vapor bubbles in the body of liquid. Okay, in the body of the liquid, boiling is characterized by formation of the vapor bubbles in the body of the liquid. Okay, bubbles formation is absent. Bubble formation is absent in the evaporation process, and in comparison with boiling, evaporation proceeds at slower rate. Okay, in this is the way. Okay, proceeds at the slower rate. Okay, in steam power plants, the steam is generated or formed in a boiler at constant pressure, except for short initial period of starting up. Okay. Okay, first now we'll discuss about the next we'll discuss about the drainage fraction and degree of superheat. Drainage fraction and degree of superheat. Okay, the quality of wet steam and superheated steam is specified by Drance fraction. Okay, what is what is the use of the Drance fraction? The quality, we should know the quality of wet steam and superheated steam is specified by Drance fraction and degree of superheat respectively. Okay, they both are used for the find the quality of for the quality. Okay, what is first we'll learn about the what is dryness fraction. This is very important. Okay, dryness fraction is defined as the ratio of mass of dry steam to the total mass of wet steam. Mass of dry steam to the total mass of wet steam. Okay, this is known as dryness fraction. Okay, mass of dry steam to the total mass of wet steam. This is known as dryness fraction. Mass of dry steam to the simply we can say as mass of dry steam to the mass of wet steam. Okay, this is a dryness fraction. Okay, okay, what is this degree of superheat? Okay, heating the steam heating the steam to increase the temperature, heating the steam to increase the temperature above the saturation temperature, heating the steam to increase the temperature above the saturation temperature corresponding to given pressure is called superheating. Once again I will explain, this is very important, both are very important. Okay, in this heating the steam to increase the temperature, heating the steam to increase the temperature above the saturation temperature corresponding to given pressure is called superheating. Okay, the increase of temperature of steam during superheating is called degree of superheat. Okay, in this what is this heating of steam? This heating the steam to increase the temperature. Okay, heating the steam to increase the temperature above the saturation temperature corresponding to given pressure is called superheating. The increase of temperature of steam during superheating is called degree of superheat. Okay, okay, the degree of superheat measured by difference between the temperatures of superheat steam and the saturation temperature at a given pressure. Already I have said the degree of superheat. Okay, in the formation of steam. Again, once again I am explained. Okay, okay. What is this degree of superheat? Okay, degree of superheat is measured between the difference between the temperature of superheat and the saturation temperature. The actual temperature, we can say actual temperature also, or saturation temperature at a given pressure. Okay, Tg is the saturation temperature. Okay, actual temperature to the saturation temperature. Actually, okay, the superheated steam also known as actual temperature, and the saturation temperature is the Tg. Okay, degree of superheat is nothing but the superheated minus Tg. T superheat minus Tg. Okay, this is the degree of superheat. Okay, okay. Next, we'll discuss about in this properties of steam. Okay, okay. So some more we'll learn about the properties of wet steam. In this properties of wet steam, we will learn about the enthalpy of wet steam. Okay, and specific volume of wet steam, entropy of wet steam, and entropy of water. Okay, entropy of water and evaporation. Entropy of evaporation. Okay, in this first we learn about the enthalpy of wet steam. Okay, 1 kg of wet steam has if the 1 kg of wet steam has a dryness fraction of x, it will consist of x kg of dry steam and 1 minus x kg of saturated water. Okay, therefore what happens is enthalpy of wet steam is equal to enthalpy of saturated water plus enthalpy of dry steam. Okay, okay. In this again we'll learn about the external work of evaporation. What is this external work of evaporation? Okay, external work of, you can see on my screen, what is it? Can external work of evaporation? During evaporation there will be large increase in volume. During evaporation there will be large increase in volume at constant pressure. Okay, the work done due to change in volume from VW to VS is called external work of evaporation, is known as external work of evaporation. Okay, once again I will explain you. During the evaporation there will be large increase in volume at constant pressure. Okay, the work done due to change in volume from VW to VS is called external work of evaporation. Okay, what happens is external work of evaporation, WE is equal to P of Vg minus Vf. P of Vg minus Vf, where Vw is very small, hence neglected. Therefore, W is equal to P into Vg. The steam formed is wet with Dreyer's fraction of x, then the final volume of wet steam is x into Vg, x into Vg. Therefore, wet steam is equal to W is equal to P into X into Vg. Okay, this is the external work of evaporation. This is the external work of evaporation. Okay, external work of evaporation W is equal to that is Px Vg. Okay, next we'll learn about the internal. We have learned external. Now we'll learn about the internal latent heat. What is this internal latent heat? Okay, the part of latent heat of evaporation is utilized. The part of latent heat of evaporation is utilized to do the external work, external work of evaporation, and the balance is true latent heat. This true latent heat is called internal latent heat. This is known as HFGI. We also known as HFGI. Okay, the part of latent heat of evaporation is utilized. The part of latent heat of evaporation is utilized to do the external work of evaporation. The balance is a true latent heat. This true latent heat is called internal latent heat. The true is known as internal latent heat. Okay, we have this formula of internal latent heat HFGI is equal to HFG minus P into Vg. Okay, therefore HFGI is equal to X dot HFG minus PXVG, that is PXVG. Okay, we have learned about the internal latent heat. Now we learn about the internal energy of steam. What is this internal energy of steam? Okay, the internal energy of steam is actually the actual energy stored in the steam above 0 degrees. Okay, above 0 degree. What is this internal energy? Internal energy defines nothing but the internal energy of steam is the actual energy stored in the form stored in the steam above 0 degrees. Okay, the heat added above 0 degrees compares work of evaporation. Okay, therefore internal energy of steam is obtained by subtracting the external work of evaporation from the total heat. Okay, how it will be solved? Nothing but the internal energy of steam is obtained by how we will get the internal energy of steam. Okay, simply by subtracting the external work from the total heat, external external work of evaporation from the total latent heat. Okay, therefore what happens, this internal energy U is equal to enthalpy of steam minus work of evaporation. Enthalpy of steam minus work, the U is equal to Hg minus P into Vg. Hg minus P into Vg. Therefore P is known as, what is P? Pressure in kilonewton per meter square. Pressure in kilonewton per meter square. Okay, if the steam is wet, if the steam is wet with the Dreyer's fraction x, then what happens? U is equal to h wet minus PV Vs. Okay, PV Vs. For supersaturated, U is equal to H supersaturated minus P into V supersaturated. P into V supersaturated. Okay, in this first we'll learn about the steam tables. Okay, properties of steam in this well-level steam tables. In order to facilitate competition, the properties of saturated steam and the saturated water and steam, nothing but the dry steam and superheated steam, have been it is tabulated as a function of pressure and temperature. Okay, we can available the see in the steam tables. Okay, next is the property of diagrams. What is this property diagrams? Okay, the property diagrams are extremely useful in the study of variation of properties during the phase change. Okay, what is the use of this property diagrams? Okay, in these property diagrams are extremely useful in study of variation of properties during phase change. Okay, the temperature enthalpy and the TH, temperature entropy TS, enthalpy entropy HS, and pressure volume PV diagrams for the vapor. We will now discuss about these things. First we'll discuss about the temperature enthalpy TH. You can see on my screen there is a temperature enthalpy diagram. Okay, the effect of pressure on saturation temperature. Okay, the effect of pressure on the saturation temperature, you can see on my screen. There's a TH diagram. This diagram is produced by plotting the curve. This diagram is produced by plotting the curve for various pressure values, for various pressure values. Okay, the saturated water line is obtained. The saturated water line is obtained by joining the saturated water points at various. Wait a minute. Okay, the saturated the diagram produced by plotting the curves. Okay, for various pressure values, the saturated water lines is obtained by joining the saturated water points at various pressures, and similarly, saturated steam line is obtained by joining the saturated steam points. Okay, the two curves divides the. Okay, the two curves divides the diagram into three regions. Okay, you can see to the left of the saturated water line, to the left of the saturated water line is the liquid phase, nothing but water. The region between the saturated water line and the steam line represents the water, nothing but liquid vapor phase, nothing but the wet phase. Okay, the region to the right, right of the saturated steam line represents the superheated vapor phase. Okay, vapor and superheated steam, where the temperature of steam is greater than the saturation temperature corresponding to the given pressure, corresponding to the given pressure. Okay, in this in okay, just wait a minute. Okay, in this what is it, we can see the critical point. What is this critical point? Okay, if the two curves, nothing but the water line and steam line, if produced they meet at a point is called critical point. Okay, the critical point is the critical point is the okay the two curves, water line and steam line, is if produced they meet at a point called critical point. The critical point is the final point. Critical point is the final point of evaporation, nothing but the latent heat of critical point is zero. There is a latent heat of is zero. The water changes directly into the dry stream. The water directly changes into the dry steam. Okay, you can see this occurs at a pressure of 221.2 bar and temperature of 374.15 degrees. Okay, above the critical point, the region represents the gaseous phase, which cannot be liquefied by increasing the pressure while maintaining a constant temperature. Thus, the vapor above the critical point behaves like a perfect gas. Okay, once again I will tell you what is critical point. Okay, the two curves, nothing but the water line on the water line and the steam line, if produced, okay, if produced they meet at a point called critical point. Okay, the critical point is the final point of evaporation. The critical point is the final point of evaporation, nothing but the latent heat at the latent heat of the critical point is zero. Okay, the water, nothing but the water changes directly into dry saturated steam. Okay, this occurs at a pressure of 221.2 bar and temperature of 374.15 15 degrees, 374.15 degrees. Above the critical point, the region represents the gaseous phase, which cannot be liquefied by increasing the pressure while maintaining a constant temperature. While maintaining the constant temperature, okay, the vapor above the critical point behaves like a perfect gas. Okay, next we learn about the this temperature. We learn about the temperature entropy is the TS diagram. Okay, you can see on my screen there's a temperature entropy diagram. Okay, temperature entropy diagram frequently used in the analysis of thermodynamic processes and cycles. Okay, this is mainly used in the analysis of thermodynamic process and cycles. Okay, in this TS diagram, heating of water at a constant pressure, heating the water at constant pressure is, you can see. Okay, the outstanding characteristics of this TS diagram is that the heat transfer is represented by the area under the diagram. You can see the diagram. This it is possible to find the quantity of heat involved in this process. You can find the quantity of heat involved in the process. You can see A to B, and from B to, you can have the critical point. From there you can C dash to C, that is the saturation temperature line. Okay, these are the lines of constant dryness fraction. Okay, this is the temperature and what we say temperature and entropy diagram. Okay, next we'll learn about the just wait a minute. Okay, I will look at the screen. Okay, this is the HS diagram. Okay, this is the HS diagram. Okay, what is the HS diagram? Enthalpy and entropy. Enthalpy and entropy diagram. Enthalpy and entropy diagram. Okay, the enthalpy and entropy diagram for steam was suggested by Moeller. Okay, first we have the Moeller chart. Okay, this is a Moeller chart. We can simply as in enthalpy entropy, or we can say as Moeller chart. Okay, is also known as Moeller diagrams. Okay, in this the enthalpy of steam is plotted on in this you can see on enthalpy of steam is plotted on y-axis and entropy on x-axis. Okay, you can see h on the enthalpy, and you can see the x-axis as a entropy, s, as you can see on my screen, h and s. Okay, this is a very important. This is h is the, okay, the h and s. Okay, h and s. Okay, the portion below the dry saturated line, represents wet steam. Okay, the portion below the dry saturated steam represents the wet steam, while the upper portion represents the superheated steam. The upper portion represents the superheated steam. The constant pressure lines in the wet region are straight and diverse with increasing quality, but they are curved in the superheating heating region. The chart is widely used for finding the enthalpy drop in isentropic process, and also finding the quality of steam after isentropic expansion. Okay, this chart is mainly used in this following points. Okay, used in finding the enthalpy drop in isentropic process, and also finding the quality of steam after isentropic expansion. Okay, next we'll learn, last one is the PV diagram. Last we'll learn about the PV diagram. Okay, okay, just wait a minute. Last we'll learn about the PV diagram. Okay, PV diagram. In this PV diagram, okay, it is used to find the constant temperature lines. Okay, constant temperature lines. Okay, actually I don't have the figure. Okay, no problem. Okay, in this way, this is used PV diagram, like in the pressure volume diagrams. Okay, in this till now we have discussed about the what is steam, what are the properties of steam, and how the formation of steam takes place. And we have learned the different formation of steam stages, nothing but the how the steam will be formed, and how the what is saturation temperature, what is this sensible heat, and what is this total sensible heat or total heat. Okay, what is this latent heat, what is heat of superheat, what is degree of superheat. And also we have learned different types of definitions in this. Okay, saturation temperature, saturation pressure, sensible heat, latent heat of vaporization. And also we have learned the subcooled or undercooled water, and we have learned saturated water. Okay, also we have discussed about the types of steams. Okay, types of steams with the wet steam, dry steam, and superheated steam. And also we have learned about the very important dryness fraction and degree of superheat. Okay, dryness fraction we have learned depend by x is equal to ms by mw plus ms, nothing but the it's a ratio of mass of dry steam to the mass of wet steam. Okay, also we have learned the properties of wet steam, and also we have learned the external work of evaporation and internal latent heat. Okay, we have learned internal latent heat. Okay, also we have learned about the property diagrams. In this property diagrams we have learned about the TH diagram. Okay, what is this TH diagram? Temperature enthalpy diagrams we have learned, and we also learned temperature entropy TS diagrams, and we have learned about the enthalpy entropy HS diagram, the molar diagram, and also we have learned about the pressure volume diagrams. Okay, therefore for vapors, the water vapors. Okay. Okay, this is today's topic. Okay, we will discuss remaining in the next class. Okay, thank you very much.